Welcome to Money and Markets, Series 1, Lesson 4. This episode is called Spot, Forward, and Discount Factors. In Lesson 1, you learned that $1 today is worth more than $1 tomorrow. In Lesson 2, you watched the exponent turn patience into wealth. In Lesson 3, you subtracted inflation to find the real rate. Now we ask a sharper question. You know what the bank offers you today for a 1-year deposit. You also know what it offers for a 2-year deposit. But what if you want a deposit that starts 1 year from now and runs for 1 more year after that? That question, which sounds simple, creates a whole new kind of interest rate. It is called a forward rate. This episode builds 3 tools: spot rates, discount factors, and forwards. By the end, you will be able to turn any future payment into a price you can evaluate today. That is the grammar underneath every bond, every swap, and every option in finance. First tool, the spot rate. A spot rate answers one clean question. What annual return does the market offer right now for money that starts today and arrives at a specific future date? The word spot means now. You commit your money at this instant, not next week, not next year. Now, here is an example with 2 spot rates, both observable today. The 1-year spot rate is 4%. That means if you invest $1 today, the market promises you $1.04 in exactly 1 year. The 2-year spot rate is 5% per year. That means if you invest $1 today, the market promises you $1 times 1.05 squared in exactly 2 years. That comes to about $1.10. Notice something. The 2-year rate is higher than the 1-year rate. That upward slope is the normal yield curve you met in Lesson 2. Now we are putting numbers on it instead of just drawing the shape. Second tool, the discount factor. Watch the screen as the formula builds one piece at a time. B of 0, t equals 1 divided by 1 plus r of 0, t raised to the power t. In plain English, B of 0, t is the price you pay today for a promise of exactly $1 delivered at time t. Let us plug in the 2-year spot rate. R of 0, 2 is 5%, which is 0.05 as a decimal. 1 plus 0.05 is 1.05. Raise that to the power 2. 1.05 times 1.05 equals 1.1025. Now divide 1 by 1.1025. You get approximately 0.9070. That number means something concrete. To receive 1 guaranteed dollar in 2 years, you would pay about 90.7 cents today. That is discounting. You already know it from present value in Lesson 1. The discount factor is just a cleaner label for the same idea when the rate comes from the spot curve. Now the question that creates a brand new kind of rate. Suppose you do not want to invest today. You want to invest 1 year from now for 1 additional year. What rate should you expect for that delayed deposit? You cannot just use the 2-year spot. That rate assumes your money starts today. Your money does not start today. It starts in 1 year. You also cannot just use the 1-year spot. That rate tells you what happens from today to year 1. You need a rate from year 1 to year 2. The rate that fills that gap is called a forward rate. In the standard notation, it is written f of 1, 2. That means the implied rate starting at year 1, ending at year 2. Think of the timeline on screen. Year 0 to year 1 is covered by the 1-year spot. Year 1 to year 2 is the unknown. The forward rate, f of 1, 2, is the number that makes the 2 pieces fit together so that no one gets a free lunch. Here is the key idea that pins the forward rate down. No arbitrage. Imagine 2 strategies for turning $1 today into the most dollars in 2 years. Strategy A. Invest directly at the 2-year spot. $1 grows to 1 plus r of 0,2, raised to the power 2. With our numbers, that is 1.05 squared, which is 1.1025. Strategy B. Invest for 1 year at the 1-year spot. Then reinvest the proceeds for 1 more year at the forward rate f of 1,2. $1 grows to 1 plus 0.04 times 1 plus f of 1,2. Now here is the rule. In a competitive market with no transaction costs, those two strategies must produce the same result. If strategy A paid more, everyone would choose A, and no one would roll short. If strategy B paid more, everyone would roll short, and no one would lock the 2-year rate. Competition forces them to be equal. That equality is what defines the forward rate. Let us solve for the forward rate. Watch the formula build on screen. The no-arbitrage condition says 1 plus r of 0,2 raised to the power 2 equals 1 plus r of 0,1 times 1 plus f of 1,2. Rearrange. 1 plus f of 1,2 equals 1 plus r of 0,2 squared divided by 1 plus r of 0,1. Now plug in the numbers. The numerator, 1.05 squared. That is 1.1025. The denominator, 1.04. Divide. 1.1025 divided by 1.04 equals approximately 1.0601. Subtract 1. F of 1,2 is approximately 0.0601, or about 6.01%. So the forward rate from year 1 to year 2, implied by today's spot rates, is roughly 6%. That is higher than either spot rate. It has to be because the 2-year spot is above the 1-year spot. The forward is the rate that fills the gap and keeps the no-arbitrage equality balanced. What does 6% actually mean? Is the market predicting that next year's 1-year rate will be 6%? Not exactly. The forward rate is a break-even, not a forecast. It says, if you lock the 2-year spot today, and it turns out that next year's actual 1-year rate is exactly 6.01%, then both strategies would have given you the same result. You would be indifferent. If next year's actual spot turns out higher than 6%, then rolling short deposits would have been better. You would have earned more by waiting. If next year's actual spot turns out lower than 6%, then locking the 2-year rate today would have been better. You got a deal. The forward rate is not a crystal ball. It is a consistency condition. Markets are pricing the relationship between maturities so that no one can borrow at the short rate, lend at the long rate, and pocket a guaranteed profit with zero risk. That discipline, no free arbitrage, is the single most important idea in all of fixed income. Now step back and see 3 curves that live side by side. First, the spot curve. This is the set of spot rates across maturities. 1 year, 2 years, 5 years, 10 years. It is the headline curve you see quoted in the news. Second, the forward curve. This is the set of implied forward rates, derived from the spot curve using the no-arbitrage formula. It tells you what the market has priced in for future subperiods. Third, the discount curve. This is the set of discount factors, B of 0,t, for each maturity. It tells you the actual present value weight you would apply to a cash flow at each date. All 3 curves carry the same information, just viewed from different angles. If you know the spot curve, you can derive the forward curve and the discount curve. If you know the discount curve, you can recover the spots and the forwards. In the real world, every government curve sits on this backbone. Corporate borrowing adds credit spreads and liquidity premiums on top. But the clean, risk-free version is where we start. Why should you care about any of this before derivatives even enter the room? Because every financial instrument you will ever study is just clever discounting and forwarding of cash flows. A bond? A stream of coupons, each discounted by the right B of 0,t. Sum them up. That is the price. A swap, two legs of cash flows, each discounted to today, and the fixed rate is chosen so the present values match. An option, more complicated but the same principle, future payoffs probability weighted, then discounted back to today. If you can draw a timeline, label the cash flows, and multiply each one by the right discount factor, you have already learned the operating system underneath most of finance. The rest of this series, and honestly every lesson that follows, is adding layers of sophistication on top of that one idea. So take a moment, make sure you are comfortable with spot rates grow money forward, discount factors shrink future money back, and forward rates stitch the subperiods together. 3 takeaways to carry forward from this lesson. 1. Spot rates are the market's current offer for money delivered at a specific future date. Discount factors translate that into a price. B of 0,t tells you how many cents today by $1 at time t. 2. Forward rates are implied by the spot curve through the no-arbitrage condition. They are break-even rates, not forecasts. If both strategies for reaching the same future date must cost the same, the forward rate is the number that balances the equation. 3. Spot, forward, and discount are 3 views of the same data. Know one curve and you can derive the other 2. Next lesson, we talk about what happens when rates are not locked in. Variable rates, flex certificates of deposit, and the reset risk that comes with letting the bank change your coupon. I will see you in Lesson 5.